I would like to draw.
I have mom. I have mom.
I would like to draw a compound for you, and I just want you to try and count the carbons and count the hydrogens on it. That's all I want you to be able to do. I would like you to count the carbons and count the hydrogens for me, please. Already done. You already took that. Okay, let's try this. How many carbons are here? 6, right? So there's one at the beginning and end of every single bond. So I see 1 here, 1 here, 1 here, 1 here. That's 4. And then there's 1 at the end of this one and 1 at the end of this one. That's X. So this is C6. And you could count the hydrogens. You could just figure out how many are on there. So how many hydrogens are on this carbon here? There are 3, right? Because there's only 1 bond attached to this carbon. So there's 1, 2, 3. So 3 there, and then you could add them all up, whatever. But you could also use the formula. Do you only see single bonds here? Do you only see single bonds? Or are there any double bonds here? I don't see any double or triple bonds, right? So I only see single bonds, so that means it'll be CnH2n plus 2. So 6 times 2 is 12, plus 2 is 14, H14. So let's just double check. Okay, there's 3 hydrogens on this one, okay? How many hydrogens can be on this carbon? 1. So 1. How many hydrogens there? 1. How many hydrogens on the terminal carbon? 3. How many hydrogens on the terminal? 3. 3, right? So we see, okay, 6, 12, and 14. Perfect. No problem. So C6H14. Was that okay? It's going to take a little bit of getting used to, maybe? Yes, and Jenna.
So if we don't understand what you just did there,
yeah,
could we draw a structural diagram? So like I was able to figure out that we had 6 carbons right from the beginning, right?
Yep.
Could we draw a structural diagram with 6 carbons and then figure out how many hydrogens come off of that?
Totally. Yeah, so what you could do, right, is you could say, okay, there's a carbon, a carbon, a carbon, and a carbon. There's 4 carbons all in a row. And then off of that second carbon, there's another carbon. And off of the third carbon, there's another carbon. And then you could just fill in all the hydrogens if you wanted to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right? Yep. That would be totally fine. Okay, so as long as we're kind of okay with, going back and forth between structural and line diagrams and condensed diagrams, then we'll be okay. It will be all right. This is where we finished off yesterday. We started naming these compounds, and I look at this left and right. Are we going to answer the question we almost got to? This one? Yeah. So I want us to just think about this for a second. This is us naming this. This is us naming this way. So how many carbons are in my parent chain? 7. Okay, 7. Perfect. No problem. And this was carbon number number 1, 2, 3, 4, 5, 6, 7. So where are the branches coming off of this parent chain? 3 and 5. When you add up 3 and 5, what does that add up to be? 8. That adds up to be 8. Now, there's a different way I could have numbered all of these. Instead of numbering them like that, I could have numbered them from right to left. So 1, 2, 3, 4, 5, 6, 7. So where are the branches here? 3 and 5 still. Okay? So that's only because it's a coincidence. It's not always going to be like that. But 3 and 5 makes 8 again. Now, what's the name of this molecule? Have I actually changed the molecule? No, I haven't changed the molecule at all. So I just want to bring your attention to something. How would I name the molecule if I had numbered it like this? If I had numbered it like this, how would I name it? It's would you agree it's still going to end in heptane? Okay, so heptane. I'm going to do this in red, sorry. So it's still going to end in heptane. Now, where is my ethyl group? What is it attached to?
3.
This time, it's attached to the 5. The previous in the previous way, just stick with me for a second. Just stick with me. I know this is tough. Okay. So this is a 5 ethyl group. Why is it an ethyl group? Because there are 2 carbons on here. Do you see that? Coming off of this carbon, there is a 2-carbon branch. We call it an ethyl group. And it's located at carbon number 5. Now this is what? A methyl. It's a 3-methyl group. So what we're going to do is we're going to arrange these in alphabetical order. So the 5-ethyl goes first, and then the 3-methyl, right? And we always have dashes between letters and numbers, and then we say heptane. Now here's the problem. We have to agree, every single one of us has to agree on one name for an organic compound. We have to absolutely agree, because if I'm in Spain and I'm calling this molecule one thing, and you're in Japan and you're calling this molecule a totally different thing, how are we going to agree? Do we know we're talking about the same molecule? No, so we have to come up with one naming system. And this is the most difficult part of naming here. It's just little tiny things like this. Do you agree 3 plus 5 is 8, 5 plus 3 is 8. So we can't use the lowest total number of branches. Does that make sense? Yeah. So if for example, if I had a compound like this, and I had a methyl coming off here and a methyl coming off here, would you start numbering from the left, or would you start numbering from the right? Where are the branches closer to? The right. So you have to start numbering from the right. But here, there's one located equally as close to that end and one located equally as close to that end. So we're running into a problem. Why did I put ethyl before methyl? Alphabetical order. So let's just, this is probably never going to show up on the diploma exam. I just need us all to pay attention to this. Which one of these would you rather name it? Would you rather give the ethyl the 3, or would you rather give the ethyl the 5? The 3. Are we okay with that? Yeah, because there's no difference between the numbers now, then we'll assign the one with alphabetical priority the lower number. Okay, it's a little idiosyncratic rule that it's probably never going to show up. You'll probably never see it again for the rest of your life. But I need you to understand that we're not going to call it 5-ethyl 3-methyl heptane. We're going to call it 3-ethyl 5-ethyl heptane. So let's get some practice in here, and let's try and figure out some names of some things. Corona.
So did you go with the lowest number
Oh, yeah, you should always go with the lowest combination between these two. So, for example, if you had the choice between a 2 and a 5, or numbering the other way, it was a 3 and a 7, which one would you choose? 2 and 5. So you just have to start numbering from the side where if you added up all the branches, they add up to the lowest number. Does that make sense? Yeah. So let's see that in action here. Let's take a look at this first chemical and reread your rules. What is rule number 1? Find the longest parent chain. So go straight from one end to the other. Try and find the longest parent chain for me. So we're just doing the top one right now, right? So what is it? Is the longest parent chain like a propane, butane, pentane? It should be a butane, right? Are we okay with, we're just happy with this being our longest parent chain? Yeah, okay. So what's the end of this molecule going to be named? Butane. Remember, it's butane because it's an alkane. It only contains carbon-carbon single bonds. Now, let's identify where are the substituents. Where are all of the branches? Do you want to start numbering from the left, so go 1, 2, 3, 4, or do you want to start numbering from the right and go 1, 2, 3, 4?
Left to right. Left.
Unequivocally, we want to go 1, 2, 3, 4. Why? How? Let's add up all the numbers. This thing is attached to carbon number 2, so that's a 2. This thing is attached to carbon number 2, and this thing is attached to carbon number 3. So what's 2 plus 2 plus 3?
5.
Wait. 7, right? Okay, so when we do it like that, it adds up to be 7. Okay? We've all been there. Don't even think that you've never been there. Okay, so what if we numbered it from the other way? What if we went 1, 2, 3, 4? You'd have 1, 2, and you'd have 2 3s. So what's that add up to? 8. So what would you rather take? A total of 7 or a total of 8? 7. A total of 7. So this is all stuff you can do in your head. You don't have to write it down. This should be all stuff that you could do in your head. Okay. So we know for sure we're going to be numbering from the left. So 1, 2, 3, 4. Now, what types of branches do we have? Do we have any methyl branches? Yes. Yeah, do we have any ethyl branches? No. Do we have any propyl branches? Okay, all right. How many carbons are in this one branch here? 1. So that's a methyl group, right? How many carbons are in this branch?
2.
Oh, that's ethyl.
1.
That's 1, right? No. Because is there a difference? Is there a difference between that and this?
Yes.
Why? Prove to me that there's a difference.
There's one branch there.
Okay, so what? So the top one here, the top one here, what's the ending of this name going to be? Butane. What's the ending of this thing going to be called?
Pentane.
Pentane.
Because you have a longer
Does that make sense? This is your longest parent chain now. Is there a difference between those two things? Oh, big time. You better believe there is, right? So this is, I want to be very clear. This will react differently, not totally differently, but it will react differently than this. There is a big difference between these two chemicals. So Alicia, that was a fantastic question. Can you not just call this an ethyl group? No. You have to look at each branch totally separately and independently of everything else. So there's a methyl group here and a methyl group here. Okay. So let's actually answer the question. I know there's a methyl group on 3, and I know there's a methyl group on 2 and another methyl group on 2. What? How many methyl groups are there?
2.
3.
In total, how many methyl groups are there? Let's look. 1, 2, 3. I see 3 methyl groups. So what I would say is this is going to be trimethyl. So we're using a prefix on our prefix.
Whoa, too much.
Are we okay with that? So
Yeah.
trimethyl, what does trimethyl mean? There are 3 methyls. So naming a substance is all about communicating what's in the substance. So let's tell the lovely people at home and on YouTube where all of these methyl groups are located. Where's the first methyl group located?
2.
It's on the 2. Where's the second methyl group located? On the 2. Where's the third group located? On the 3. 2, 2, 3 dash trimethylbutane.
No, that's so magic.
I'm not okay with this.
I know you're not okay with this. Do you remember when I said yesterday? Is that you just have to accept that organic chemistry is going to happen. You just have to be okay with it. You have to roll with it. And as soon as you accept that this is going to happen, then life becomes so much easier. Okay.
So if I just wrote the 2 once, is that wrong?
No, you can't. You can't just write the 2 once, because how many methyl groups are there?
3.
There are 3, so you have to tell me the locations of all 3 methyl groups. Okay? So what I want to do, I want to ask you a question. I want to ask you a question. Yep. So if I said you had 3, 4 triethyl, diethyl, thank you. Diethyl, 5 methyl octane.
Oh.
I don't like that.
Wow.
Okay, let's just look at this. No, it's okay, it's okay. I totally get. I totally get that there's just a metric buttload of things going on here, okay? But that's fine, whatever. Let's go back to front. What the hell does octane mean? 8 carbons in a row, right? 1, 2, 3, 4, 5, 6, 7, 8. So let's just number these 1 through 8 in our heads. So what do you have attached to carbon number 5?
Methyl octane.
You have a single methyl group, right? So which one is carbon number 5? 1, 2, 3, 4, 5. You have a methyl group attached to carbon number 5. Does that make sense? Yeah, you're just saying 5 methyl. The methyl group is attached to carbon number 5. And then let's work our way backwards again. You have how many ethyl groups? 2 of them. And where are they located? At 3 and 4. So I'm going to go to 3. And it doesn't matter if you're on top or on the bottom. Remember, because the bonds can spin, it doesn't matter. So where do you want to put the carbons, this ethyl group, on the bottom or top? Top, sure, top, whatever, doesn't matter.
No.
Wow.
There's 3 there.
What?
3 and 4 at the bottom. Yeah, you're right. Put the other one on the bottom.
Okay, sure, whatever. whatever. Fine, let's do the other one on the bottom. So, do you agree? At carbon number 3, we put one of our 2 ethyl groups here. Yeah, there's right off of our branch, right? You just have to ignore the carbons on the branch or on the parent chain. Off of our parent chain, how many carbons are in this branch? 2. That's why we call it an ethyl group. Okay, and then where is the other ethyl group? On 4.
That's still right.
Whatever, doesn't matter.
They didn't like that.
So is this okay?
Yes.
And then you just fill in the hydrogens. That's all you gotta do. The name, if you work back to front, the name becomes much simpler than working forwards to back. So it's an octane, 8 carbons. I've got a methyl group at carbon 5, just one of them. I've got 2 ethyl groups, one at 3 and one at 4. So let's look at this now. Let's try and, okay, Max.
So using the carbon formula thing with the CN, like,
Yeah.
Does that work if we do like the 8 plus and 5 carbons?
Oh, totally. Yeah. How many carbons are in this bad boy? So we got 8, 9, 10, 11, 12, 13. And then, so how many hydrogens are going to be in here?
6 plus 2, 28.
28? So C13H28. Because there's only single bonds in here, right? Yeah. And if we wanted to, we could work it out by hand. We could say, there's 3 carbons on the first one. How many carbons are on the, or how many hydrogens are on the second carbon? 2, right? How many hydrogens are on the third carbon? Just 1, right? Because every carbon needs 4 bonds. Okay, I personally find going from names to formulas or names to structures way easier than going from structures to names. So that's why we're doing the hard one first, because it really, we just want to focus on this and then move to the easy one. What's step number 1 in naming this thing? Longest parent chain. You tell me, what is the longest parent chain here? Is it a pentane, a hexane, or a heptane? It's beyond the shadow of a doubt. It is a hexane, right? There are 6 carbons in this parent chain. Why? Could go up or you could go down, right? Okay, so what do you want to do? Do you want to go down or do you want to go up?
Up.
All right, whatever. That's our parent chain. Sure, whatever. Okay, let's try and number this. Do you want to number from left to right or from right to left?
Right to left.
You want to start from right to left? Let's double check. So you're going to have, this is going to be a 3-methyl group. Do you agree this would be a 3-methyl group? And then what about this here? What the hell's that? That's an ethyl, and what is it attached to?
3.
Carbon 3, so that's going to be a 3-ethyl group. And then what about the last one? That's going to be, it's attached to 1, 2, 3, 4, 5. It's attached to carbon number 5, and it's a methyl, so that's a 5-methyl group. So if we numbered it from right to left, what would be the total sum of all of these numbers?
11.
That's 11, okay? Now, just in our heads, let's do it the other way. Let's count up the branches, do it going the other way. So there would be a 2, and then 1, 2, 3, 4, and there would be a 4 and a 4. What's 2 plus 4 plus 4? 10. So you actually want to start numbering left to right. Does that make sense?
Yes.
So the way, if we numbered it from right to left, it looks like both of these branches are closer to the right-hand side. So you want to think, okay, let's number it this way. But you actually have to check and see. So we're going to number this 1, 2, 3, 4, 5, 6. So that means
Can you explain one more time why we're starting from that end?
yes, totally. Okay. In blue, we numbered from right to left. Is that okay? So 1, 2, 3, 4, 5, 6. So we ended up with a 5-methyl. Are we okay with that? We ended up with a 3-methyl. It's a methyl group attached to 1, 2, 3, the third carbon. And we ended up with an ethyl group attached to the third carbon as well. So when I added up all these numbers, 3 plus 3 plus 5, that added up to be 11. So the sum was 11. Now we're going to do this using red, and we're going to do it from the left to the right. So instead of being a 5-methyl, what's this going to be? A 2-methyl. Okay, so this is going to be a 2-methyl. And instead of being a 3-methyl, what's this going to be? A 4-methyl. And instead of being a 3-ethyl, it's going to be a 4-ethyl. And then so when we go left to right, the sum is 10. So you have no choice. The choice is taken out of your hands. You have to number this from left to right. Now, I want to be very clear. It didn't matter if we went up with our parent chain or if we went down, because this was an ethyl attached to carbon number 4, but this would have been an ethyl attached to carbon number 4, so it didn't really matter. Yeah.
Is this one of those fun teacher things where we're supposed to do it manually, but then 2 weeks later there's an easier way to do it?
Nope.
Damn.
Yeah, this sucks. But you honestly, it's like tying your shoes. It's you some kids hate it in the beginning, and they hate it and they hate it and they hate it, and they think, oh man, why can't I just use Velcro all the time? And you're just like, well, you know, this is going to be something you do every single day, and it's going to be easy, and it's going to be just natural for you. And this is going to be like tying your shoes by the end of the week. Yeah. Yes, and that's exactly what we dealt with here, where it was the same sum going both ways, right? So we went 3-ethyl-5-methylheptane, and then we went 5-ethyl-3-methylheptane. So that's where we had so we just said, okay, the alphabetical one is going to have the lower number, and then we move on. Okay, I really sincerely doubt you will ever see that, but just in case. Okay, so let's actually name this now. So we're done with the blue naming. The blues are gone now. I'm going to take these and I'm just going to put them off in no man's land. Oh, nope. There we go. She gone. There we go. Perfect. So let's try this. What's the end of this name going to be?
Oh wait, which one?
And then, okay, let's think about this. What's going to come first? Ethyl or methyl? Ethyl's going to go first, right? So we're going to go 4-ethyl first.
Why is it not diet?
Could you do like dimethyl?
Yes, we will. Totally. Yeah, you're totally right. Right? So ethyl's going to come first, so we should do the dimethyls, right? So let's go dimethyl. Because there's 2 methyls, but where are the methyl groups?
Differently.
Yeah, on 2 and 4. So we'll say 2,4-dimethylhexane. Have we labeled all of the branches? No.
Sir, wouldn't dimethyl come first because of the alphabetic?
No. This prefix doesn't count. the mono ditri. It's not there is no mono, but di, tri, tetra, penta, whatever doesn't count. Okay, so we've got a 4-ethyl group. So 4-ethyl, 2,4-dimethylhexane. Okay, does anybody want to go over that from scratch again? No? Are we okay with that? Yeah, we should.
If you accidentally forget a dash, like you like say like 2,4 and
Yeah.
then you forget the dash
Yeah.
and the dimethyl, will you like tell us first?
Yeah.
Why?
Because I'm an asshole.
How dare you? At least you admitted it.
So the reason why I'm going to dock you marks is because it's not correct. So what we do is we answer these with no spaces in between. And anytime in between letters and numbers there has to be a dash. That's just the way it is. So what I would like you to do, pretty please, and thank you, is I would like you to try the last one. It's tricky as well, but just roll with it. Yeah. Just give me a second.
Did you just do straight across? Yeah. I was gonna let the bottom Oh, don't say it. Don't say it. Don't tell me.
I'm gonna go up and down.
I know. I gotta try it first.
I said up and down.
No. That's just like a tough. Yeah.
Yeah.
It's getting mad, and you know what it's saying? You know what it's saying? It's saying 4-ethyl 2,4-dimethyl hexane.
I say,
These are the
And all he does is yeah, the only thing wrong with it, it's not yeah.
sorry.
Okay, what's our longest branch on here? It's 8 carbons, right? Yeah. Sorry. Sorry, not sorry.
I got it. It's like a look at it, snake.
Yeah.
And I need it.
That's right.
Put a little tongue on it.
Okay, so do you want to start numbering from this is weird, but kind of from left to right or from right to left? Right to left.
Left to right.
So if we went left to right, it would be 3 and a 5, right?
Yes.
So that's 8. And if we went right to left, it would be 4 and a 6. Definitely don't want to go right to left. We want to go left to right. So we'll name that. This will be 1, 2, 3, 4, 5, 6, 7, 8. So we're going to end in what? This is an octane, and it's got 2 branches. Now, are the branches the same? So you're not going to have to do di, tri, or anything like that. It's just there's one of these. What the hell would we call that? A propyl group. Yeah. But are the prefixes and how you use them, do they kind of make sense? The branches are methyl, ethyl, propyl, butyl, pentyl, hexyl, right? But you only have to name structures up to 10 carbons long, so you will never see a branch that's larger than butyl. Butyl is the largest you could possibly go. Just mathematically, with a 10 carbon parent chain, you can't go any larger than 4 carbons. So this is going to be a propyl group, and what's this going to be? Methyl. So what comes first in the alphabet? Methyl or propyl? Methyl. So we'll go 3-methyl dash 5 dash propyl octane. Why are there dashes in between? Every time you go from a letter to a number or a number to a letter, every time you have to do a dash. There are commas in between numbers and numbers, but there's no numbers and numbers, so we don't need any commas. Are we okay with that? Sure, whatever. Okay, trust me when I say drawing these substances is so much easier than naming them. The only problem is I could ask you to draw substances in how many different ways? 3 different ways. I could use structural, condensed structural, and line diagram.
But why would you ever give us something that's hard?
Why would I ever give you something that's hard?
Yes.
Come on. Okay, drawing alkanes. Start with parent chain, add branches at the numbered locations, fill the remainder with hydrogens. Carbon can only have 4 bonds. So let's try this. Draw the compound. It is start. Please, 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 just go back to front. Right? Start. No, I don't mean. I don't mean draw back to front. I mean look at the last part of the name. What's the last part of this name? Octane. So what's the first? What are you gonna draw?
8 carbons.
8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. It doesn't matter. It doesn't matter if you number your carbons. By the way, I wouldn't even number them. I like in my mind I would keep a number attached to it, right? I know that this is the what carbon? 4. The number 4 carbon. Or if you're going this way, it's the number 5. But it doesn't matter. Like, just do the same thing every time. Either always start from the left or always start from the right when you're drawing them. So let's look at this. What do you want to do? Do you want to do the propyl group first, or do you want to do the ethyl group or the methyl groups first? Let's do the propyl group first. Sure, whatever. Where's the propyl attached to?
4.
Carbon number 4. So it doesn't matter how you arrange them, as long as you have how many carbons in this group?
4.
It's on carbon number 4, yeah, but there needs to be 3 carbons in this group. So do you want to go straight up?
No.
Down.
Whatever. Do you want to go straight down?
Yeah.
Sure.
No.
Whatever.
No.
What I would do is I would go 1, 2, 3. Okay, but if you want,
Make it a little light.
you could go 1,
We could go right.
3. But if you want, you could go 1, 2, 3.
Make stairs. Make stairs.
You do one above and
If you want. If you want.
If you want,
There you go. There you go.
are we okay with that?
Yeah.
Is this 3 carbons in a row attached to the 4th carbon?
Yes.
Yes, it's a propyl group, right? Okay. And then, where are the methyl groups?
3 and 4.
On 3 and 4. So I'll go 1 down here and 1 down here. So I want to be very clear. I'm not done yet, but this is like the skeleton of this molecule. Now, let's draw in our hydrogens. How many hydrogens can we fit on that first carbon?
3.
I wanna ask you a question. On a terminal carbon, a carbon that ends up either a branch or a chain, How many are always going to go on there? 3. So 1, 2, 3. Every single terminal carbon is going to have 3 hydrogens, sure, whatever. All of the intermediate carbons, they're different depending on how many branches are on there. So 2 on this one. How many hydrogens on that third carbon? 1. How many hydrogens on the fourth carbon? 0. Right? Okay. Is this very quickly going to be a pain in your ass?
Yes.
Yes. Big time.
Oh. This is just a mess.
Oh, what a nightmare. Yeah, okay. So let me be very clear. It did not say I had to do a structural diagram, did it?
No, sir.
No. So can we represent the other 2 ways? It's going to be super easy. Don't worry about it. It's going to be super easy. What do you want to do? Do you want to do the line or the condensed diagram? Let's do the line diagram. Okay. How many carbons are in your parent chain? 8. And how do you start it again? 1, 2, 3, 4, 5, 6, 7, 8.
But on the third one,
now, on the line diagrams, you're kind of handcuffed in how you should draw them. If the carbon is kind of pointing up, your branches should point up as well. If the carbon's pointing down, probably your branches should point down. So that's just because it's the easiest way to draw it. Now, we got 2 different methyl groups. Where are they located? On 3 and 4. So let's look at carbon 3 and 4. Where do I start? 1, 2, 3. So where should I put this methyl group?
down.
Down. And you just put a line, right? Because at the end of this line is 1 single carbon. Now, where's the next methyl group? At 4. Do you see how 4 is pointing up, though? So I'll put it up. Just a single line. There's 1 carbon at the end of that line. And then, what about the ethyl that's also at carbon 4?
3.
Okay, so what I would do is I would draw it, boop, boop. Or,
That's weird.
oh, it's a propyl group, sorry. That's right, boop.
Oh. So we have to.
Okay, so Preston, your question is we can't go down with it. So if I went down like this, you could. Does it look natural to you?
Yeah.
Okay, Preston, I'm not going to mark you wrong for that. I want to be very clear. But if you ever take university organic chemistry, that's going to be kind of frowned upon. But whatever, that's totally fine. Right?
Oh, jeez. That hurt.
No, how would you know what's frowned upon and what's not frowned upon at a post-secondary institution?
As you just go.
Okay, so are we okay with this?
Yes.
Jordan, Alex? You gotta go. Okay. So this is still our 1, 2, 3, 4, 5, 6, 7, 8, our octane. And we've got methyl groups at 3 and 4, and we've got a propyl group at 4. So this is 3, 4 dimethyl, 4 propyl octane.
Whoa.
Good? Kinda good? A little bit good?
Like,
Yeah, Max.
He's gonna ask us to name the compound from the line diagram.
Oh, you better believe it.
Oh, that's very unfortunate.
Oh no.
I'm asking you to draw the condensed. So remember, so what I want to be very clear about, the condensed diagram is the exact same as the structural diagram, except you don't have to write this down, but let's say I had this. Let's just say I had this. Whatever, it doesn't matter. How many hydrogens are on this carbon? 3. So I can just say CH3. Instead of drawing all the hydrogens, right? This is a condensed diagram. So how many hydrogens are on this carbon? 2. So I just say CH2. Just leave yourself a little bit of room, that's all. How many hydrogens are on this carbon? 1. So CH, CH3, CH3, right? This is a condensed structural diagram. You're just taking the hydrogens and condensing them onto the carbons. So go ahead and draw this, and I'm going to walk around and I'm going to try and help you. Actually, no, I'm going to get something from the printer. So when I look at this, do you agree? So condensed structural diagram, we're not allowed the lines, right? We have to show every carbon, but we can just group all the carbon hydrogens together, right? So we're going to start with heptane 7. And do you like starting numbering from left to right? Yes. Yeah, that's probably what most people's priority is. Yeah. So there's 4 ethyl. So what does that mean? What goes at carbon 4?
An ethyl. 2 C's.
Yeah, 2 C's. So I'm going to go to carbon 4, and I'm going to go C, C. Right? That's fine. I could have gone C, C. That's okay. And then what's at carbon number 2? A methyl. So up or down doesn't matter. A methyl. And then you just fill in the hydrogens. And I'm going to do that super quickly, if that's okay. CH3, CH, CH3, CH2, CH, 2, 2, 3, 2, whoop, 3.
I have a question.
Yeah, sure.
On your second carbon thing, your second CH, you have like a CH3 connected to it, but you have CH3 on the left and above it. How does that work?
because remember our parent chain is heptane, and I have a methyl attached to 2. Yeah, exactly. Even if this was the parent chain, right? So there's a methyl at 2 and an ethyl at 4.
Oh, could you combine the methyl at 2 and be C2H4?
No, you couldn't do C2H4.
You know why not?
Well, first of all, that's the wrong number of hydrogens.
Like CH3.
Yeah.
C2.
Ah, man, you might see it. I can't ever remember seeing it written as C2H5. I can't ever remember seeing it written like that. There are times. Can I get everybody to pay attention for a second? Let's say I'm gonna draw one thing, and then I'm gonna show you a different way of drawing it, because you might see this on like a diploma exam. But and I don't know. I think it's a jerk way of representing it, because it bugs you if you're not paying total close attention. Let's say I had 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's say I had a methyl group at carbon 2 and an ethyl group at carbon 3. So when I look at this, okay, so we could just fill in all the hydrogens. That's totally fine. A different way of drawing this is by going so CH3, CH, CH3, H, H2, H3. And then what I want to know, all of these middle carbons, they're all what? CH, 2, CH, 2, CH2, CH2, CH2. So how many CH2s are there in a row? 1, 2, 3, 4, 5. Is that last one a CH2?
No.
It's a CH3. Okay, so you might see it written as this. I rarely do you see it like this. But does it make sense that they're just saying 5 of these things in a row and then you end with a CH3?
Yeah.
Does that make sense? I would never suggest that you draw it like this, because it's super easy to screw up. It's super easy to combine these and just say CH26 or something like that. So please don't do that. But you just keep that in mind. If you ever see this, it just means 5 of these things in a row. That's all. Yep. So that's a different way of representing it as a condensed structural diagram. Okay. Any questions about that? Okay. You tell me. You and a partner. You and a friend. You and an associate in crime. Tell me what's wrong with these 2 things.
I have no idea.
There's no 3 prime associated.
Also,
This needs to go by.
say try.
This needs to go with this needs to go.
If it is, then yeah, you need to have a try.
Right here. This is not oh wait, no, no. This is going on Megamix. Right?
There. They're 2 different things.
Yep. So they are 2 different things, right?
Yeah.
Yep. So that's what's wrong with that one.
These are 2 different things.
Yeah, those are 2. Yeah, sorry. These are 2 different molecules. So what's wrong with this? And then totally separately and independently, what's wrong with this?
You confuse me. These don't.
But this, okay, this one needs time to prove, that's for sure. Let's just try it and see.
But I agree with you. It should have been, if you were to name it, it would be pentane.
Is this supposed to be triangle?
Yeah. You know, that's there's 3 numbers there, so it should be trimethyl, right? But there's something else that's wrong.
Right there. No, that's the longest one.
They didn't put the
Why can't you just go like this, like Scrabble?
We tried. Yeah, that's what I said. He said there's something else.
I found the longest parent.
Yeah.
This one actually looks like it hurts. That one's bad. Balls. Is this correct? Would that be the longest parent chain?
Yes.
Which one?
It's like word hunt,
Should only
right?
have one hydrogen? This isn't supposed to have any.
Yes, I know, it's also has this H because
No, it's.
It would be 2, 4, 5.
I was just.
This would be correct. Please determine what a parachain stall is.
Because you have to go from one card to the bond.
Oh, yeah.
Yes.
No, you can't. No, because, so is this?
They're in the process of can't go back. You can't go back.
Therefore, that's.
That means there is not. Goes down and then back up.
Go down there.
No, it wouldn't be. So it's just two.
It's gonna be like that. So it's just that.
Then we can keep it as no. I'm this one.
I put that one. 4 or 5.
Is this right, Watson?
Yeah.
No.
No.
Come here.
Yes, you are so close to draw it out.
Draw it out.
Oh, that's his name.
You're right. Draw it out and then name it.
I think yes. And you said no. You said no. You said draw.
Okay, Joe, maybe you are right. Never mind. Maybe you are right, but maybe for the wrong reason. Okay, so I don't know your reasoning though. That's the problem. I don't know your reasoning.
That's why I said come here. But you know,
Correct.
choose for a wall.
Correct. That's the only stuff wrong with
And
that.
then this trimethyl.
Okay, let's go.
It's kind of a wall. What? You want to know my reasoning?
That's
Yeah.
fine.
Alright. So we got boom, boom, boom. Right? You add a method to it.
That's easy.
Boom, that goes out to head. And then since you add that, it's in the parent chain, so it's not really a method. How am I wrong?
Because I was like,
What happens? Where? Let's look at our Where were your methyl groups? They go okay.
Now you start on the other side.
Okay, so let's think about this. No. So, okay. Now, there's several things wrong with the first one. I love this one so much. It just discombobulates people. I love it. Okay. What is the obvious problem with this name? Trimethyl, right? Okay, so there's got to be a prefix. You have several methyl groups, so there's got to be there's got to be di, tri, tetra, whatever. But let's draw this out. How many carbons in the parent chain?
Says it's 6.
And where are the methyl groups?
1, 3, and 4.
At 1, 3, and 4. But when you draw it out, how long is the parent chain in reality? It's actually 7. So this name is wrong. It's not hexane, it's heptane. And also, where did you put like on what carbons did you put these two methyl groups originally? This was 3 and 4, right?
Oh.
Do you agree?
It's
But-
like a super step.
But by adding the carbon at the end, it's now at 4 and 5. Or is it?
No, it's the other way.
But instead of numbering it 1, 2, 3, 4, 5, 6, 7, now because we added a carbon onto that end, now actually we have to start numbering it this way.
Yeah.
1, 2, 3, 4. So the 3, 4 stays. So you're right, but for the wrong reason. Does that make sense? Did you know that you had to switch the numbering on?
Did you mark it wrong?
No, I wouldn't have. No, I wouldn't have it wrong. So this is actually 3, 4 dimethyl heptane. Okay?
Ugh.
Now, that is such a fantastically complicated question. It's like, that's like, oh man, holy guacamole. But don't worry about it. It's
not like it's your grade.
no. What I mean by that, Shelby, what I mean by that is I would probably ask you, instead of what's wrong with this chemical, I would probably say, is this an appropriate name for a chemical? And you would say yes or no.
Okay.
And then we would just move on from there, that kind of thing. Or I would ask you, I might ask you, I might say, a student named this compound, so I would give you the structure. I'd say a student named it 1,3,4 trimethylhexane or methylhexane or something. What's the actual name for this thing? And you would just straight up name it. It just becomes a naming question. Could you name this 3,4 dimethylheptane? Just if I just gave you the picture? Yeah, maybe, probably. Alicia.
So why would it be 6?
Where do you see a 6 on here? Yeah. This isn't a branch anymore. It's part of the parent chain now.
Chain.
So it's not 3, 4, 6. It's just 3, 4. Is that okay? Yeah. Sophia. Why isn't this a branch? But I drew this. I drew this compound, and then I'm going to name it properly. So do you agree I successfully put a methyl group off of the carbon 1? So now I'm not going to switch it and put it over here now because I put it there to begin with. Okay, so now we just name this. Are you going to name this 4,5 dimethyl heptane, or are you going to name it 3,4 dimethyl heptane? 3,4. Does that actually answer your question? Kind of. Okay.
Could there be like a multiple choice question where it gives you 1, 3, 4 methylhexane, and then it gives you like a whole bunch of actual names, and then you have to like choose the correct name?
Oh man. I don't want to say no because potentially yes, there could be. There could be a diploma exam question where the question says a student incorrectly named the following substance 1,3,4-methylhexane. What is the actual name for it? And it would give you this picture, and you would just have to say, okay, well, there's a parent chain here. I'm not going to name it 4,5, so I'll name it 3,4 dimethylheptane. Done. Good? Okay, I just want to introduce the idea of isomers. Now, we're a little bit behind schedule, but also we're a tiny little bit ahead of schedule as well. We're like a day ahead of schedule in the calendar, but we're a little bit behind schedule from where I was hoping to be by the end of today. Oh yeah, we never answered this. What's wrong with this one? This hydrogen, and this should just be CH, right? Yeah. Okay. I want to talk about structural isomers. Do you remember yesterday how I took hexane and I popped the end off of the hexane and then I added it as a branch somewhere else? So did the chemical formula between hexane and the 3-methyl pentane, did it change? Or was there still the same number of carbons and hydrogens? Yeah, there was still the same number of carbons and hydrogens, right? So what I want to bring to your attention is that is what we call a structural isomer. An isomer, iso means the same. So isomer means it's got the same formula, but structurally it's different. Now, you can always make a structural isomer by taking the end of a molecule off and by attaching it somewhere in the middle of the molecule. You're just trading hydrogens and like methyl groups or something like that. So I didn't lose any atoms, I just traded them. You're just taking the end of it and adding it onto something else. That's the easiest way to make an isomer. And what I would like you to do in the remaining minutes is I would like you to draw 3 different isomers for C5H12. How many? I know. It's okay. Is this, can I assign you a tiny itty bitty little homework?
Yes.
No.
It's fine. We never get homework in this class.
Draw 3 things. Draw 3 different isomers.
A little bit of room for you. It's
But they have to be structurally different. What I mean by that is you would have to name them different things. If you would name them the same thing, then they're not actually different things. That's one. Yeah. Yep. Probably the most obvious one is just everything in a line, right?